Good morning, Wabash. Speaking in chapel today will be Professor Amanda Ingram. Dr. Ingram is an associate professor of biology and currently serves as the biology department chair. She received her bachelor's degree in biology and environmental science from the College of William and Mary and her PhD in plant biology from Cornell University. Dr. Ingram joined the Wabash College faculty in 2004. Her research interests lie in plant systematics, which involves the study of plant evolution and classification, and her work is currently focused on understanding the evolution of the love grasses. Professor Ingram is a native of Virginia's Shenandoah Valley and so tries to find as many excuses as possible to travel to places with mountains in her spare time. She also enjoys playing music, tending her urban farm, and sampling her husband's award-winning homemade beers. Giving her talk titled, "How Many Species Have You Eaten Today?" Please give a round of applause for Professor Ingram.
Good morning. Hey, thanks for being here. I know what a nutty week this always is just before spring break, but I'm really pleased to see you all here. So I want to thank the Sphinx Club for inviting me to speak today. I think, as Corey can tell you, when he asked me a few weeks ago if I'd like to speak, I was really excited until I started thinking about what I might talk to you all about. Most chapel speakers choose to speak about something they're really passionate about, so I started thinking about that. And one of my passions is vegetarianism, but given the number of Midwesterners who ascribe to the cult of bacon, I just didn't really think that would go over very well. Next, I thought, another sort of common theme is to think about Wabash traditions. But I really got hung up on wondering what was inside those little sacks Rhines have to wear during their pledgeship. And I decided I'd better not go there either, so I quickly abandoned that idea. But something I thought might work a little better, though, relates to the diversity of the food we eat. We are fortunate enough to live in a country and in a time where there are a tremendous number of different kinds of foods we can access. But as I hope I'll show you today, there are some severe threats to this diversity looming on the horizon. Before I get to that, though, I'd actually like to have a little contest to start things off today. I even have a prize for the winner, so there's some incentive here. What I'd like you to do is take a couple of minutes and think about what you ate yesterday. I know that the title of the talk asked how many species you've eaten today, but probably some of you haven't eaten yet today, aside from that donut you had on the way in. So think about what you ate yesterday and count up the number of species you ate. And if you have no idea, then just give your best estimate, okay? So think about it for a minute. Okay, are you about there, or do you need more time? Okay, let's start. So, if you ate more than 5 species yesterday, raise your hands. Okay, if you had more than 10 species, keep holding your hand up. Okay, we lost a few there. 15? Okay, 20? Okay, Ethan and I are in competition. Oh, there's another one back there. How about 25? Ethan, are you being serious? Okay, 30? Okay, don't count the bacteria. How about that? Well, I'm going to give it to Dr. Hollander. That's an impressive tally there. Now, a lot of you held your hands up through 10, and that's awesome. But as I continue to talk today, I want you to think about what those species were and where they came from, and we'll explore this idea a little bit. The next thing I want to ask is how many of you have actually grown any of those species you ate? Okay, that's really exciting. I think if I had asked this question probably 5 or 10 years ago, not nearly as many of you would have raised your hands. We're living in this exciting time when more and more people are gardening or maybe raising some chickens, or if you're our future dean of the college, you might be raising a whole agricultural menagerie. And I think this renewed interest in producing food was probably one of the best outcomes of the Great Recession that we just hopefully made it through. In spite of that, I'm willing to bet that very few of you have ever seriously considered being a farmer, even though a good many of you probably grew up on a farm or had parents who did. I'm not really sure why this is, but it's pretty common for smart students like you to be discouraged from pursuing a career in agriculture. It's certainly a risky enterprise, and with the mechanization and streamlining typical in the sorts of farms that take up the most acreage in the Midwest, you don't actually need very many people to raise a great amount of food. What's been really exciting during the past few decades, though, is that more and more farmers are returning to more traditional and complex modes of agriculture. A lot of you will have read about things like this in The Omnivore's Dilemma, which I think some EQ sections probably read now. But in spite of this, I'm worried. Because of some of the fundamental changes in how we decide what we raise, even this return to the land might not be able to function as effectively as it did in the past. So it's these changes that I'd really like to talk today. I arrived at the topic I'll eventually get to while I was watching the Winter Olympics last month. Bob Costas was droning on about some newly minted Olympic events, and my mind began to wander. I was trying desperately to think of anything but conjunctivitis. It was just right there in my face. And a Russian story that I first heard as a young graduate student came to mind. I had just begun to study crop domestication at Cornell, and that, I think, is something one could argue is what made human civilization as we know it possible. And the work of a Russian scientist named Nikolai Vavilov kept coming up. Vavilov's key contribution to the study of crop evolution was proposing hypotheses about major geographical areas where most domestication occurred. But the part of his story that I found most compelling related to events toward the end of his life. So Nikolai Ivanovich Vavilov was born in 1887, which turned out to be a really great time to be born if you were to become a biologist interested in genetics and evolution. Mendel's laws and Darwin's theory of evolution had been published a few decades prior, and those works would be rediscovered and better appreciated beginning at the turn of the 20th century. By the time of Vavilov's death in the 1940s, the field of population genetics had been born, and the great modern synthesis, wherein genetic mechanisms of evolution were finally being understood, had begun as well. It's during this exciting era of discovery and insight that Vavilov trained and worked. Vavilov grew up in times of severe famine and food rationing and was determined that he would use his scientific career to improve crop plants to enhance food security. He trained in agriculture and in genetics and ultimately landed a job in Leningrad. Vavilov was convinced that the route to food security was to breed genetically superior crops, and he was also convinced that advantageous genes were bound to be found in the areas where these crops were initially domesticated. So he organized numerous seed collecting expeditions and founded an institute in Leningrad where the seed collections were stored and maintained, destined for further study and for use in improving existing crop varieties. He personally went on expeditions to 64 countries, which at the time is quite impressive, I think. And he learned to speak 15 languages in the course of that work. By the late 1930s, 250,000 samples had been accessioned at the Vavilov Institute. This was a tremendous achievement and constituted the largest seed bank at the time. You can think of it like a botanical version of Noah's Ark. It was really an amazing thing. In the meantime, however, Vavilov began to run afoul of the Stalin regime. Many explanations can be found for why he got into trouble, ranging from his unwillingness to join the Communist Party, to his family's wealth, to his public advocacy for Mendel's laws of inheritance, believe it or not, in an era when genetics were considered counter to Bolshevism. Vavilov publicly and vociferously championed his position, which was, of course, correct, as we know very well now. But his convictions resulted in his arrest for treason in 1940. He was sentenced to death the next year, and while that death sentence was commuted, Vavilov, a man who devoted his scientific career to improving food security, died in prison of starvation in 1943. Meanwhile, biologists at the Vavilov Institute carried on his work. They had amassed this tremendous collection of seeds and that continued to be supported. But conditions in Leningrad grew dire during the 28-month siege of the city in the early 1940s. People were starving as food supplies were cut off, including many of the employees at the seed bank. On the streets, the hungry were said to have resorted to cannibalism, but employees at the seed bank barricaded the building and guarded the collections. When rats tried to eat the seeds and tubers stored in the building, they ate the rats. 9 of these individuals eventually succumbed to starvation. Sorry, this always chokes me up a little bit. But when the liberators finally broke into the institute, they found emaciated survivors curled up next to sacks of the food. I've read that one of them said it was hard to wake up, it was hard to get on your feet and put clothes on in the morning, but no, it was not hard to protect the seeds once you had your wits about you. It's how important these collections were to them. The story's always been compelling to me, and while there are many important lessons to take away from the tale, the part of the story that I always found most gripping was the scientists' commitment to preserving the seed collection, even at the risk of their own lives. They could easily have cooked up the grains and legumes stored in those seed boxes and lived a few more weeks or months, possibly outliving the siege. But instead, they chose to protect the future of agriculture, and we humans who rely so much on it, by preserving the samples that might house the disease resistance gene that could save important crops from the next big threat, whatever that may be. The Vavilov Institute is still around today, and some of its collections have been used to produce some of the varieties of plants we rely upon now. So it's a really, really important legacy that they protected. This work of preserving crop diversity is something that's currently under severe threat. There are now lots of seed collections throughout the world. The USDA, for example, maintains a large collection with over 500,000 accessions from nearly 15,000 plant species. It's amazing. Your tax dollars at work, doing really good work. But warfare, inadequate funding, and natural disasters continue to imperil collections throughout the world. The seed bank in Aleppo, Syria, for example, was transported to Turkey in 2012 for safekeeping during the ongoing conflict in Syria. The Aleppo Seed Bank had done a similar favor for Iraq a decade prior. A subset of Iraq's National Seed Bank, formerly based at Abu Ghraib, was sent there for safekeeping. The seeds were ultimately returned to Iraq to help the country rebuild its agricultural system. But others have not been so lucky. Afghanistan's seed bank was lost to conflict, and the Philippines lost a major collection to a typhoon in 2006. Despite these formal mechanisms of preserving crop genetic diversity, though, there is a tremendous erosion of diversity in its customary repositories, farms and backyard gardens. Think about the farms you drive by every time you leave town. How many species do you see being grown there? 2, maybe 3 if somebody happened to grow some wheat, right? Think about the difference that is from what used to happen in this area. And the other question I want you to ask yourself is how many of those crops were varieties that farmers have developed to be most useful on their particular plot of land? The answer there is probably none. We rely on seed companies now rather than farmers doing this work themselves. But it's not like this everywhere. I went on my first plant collecting expedition in the tradition of Nikolai Ivanovich Vavilov in 2000, and I went to Ethiopia and traveled with scientists at one of the country's plant breeding centers. Our goal was to collect farmers' varieties of teff, which is a cereal crop grown almost exclusively in that country, and we ultimately deposited them in the Ethiopian seed bank. The diversity I saw of teff was remarkable. Farmers living next door to each other might have completely different varieties of the crop, different colors of grain, different plant morphologies. It was really amazing, all depending on what their family preferred or what was best suited to the microclimate found on their plot of land. Those of you who have traveled in the countryside of Ecuador or other less industrialized countries may have noticed similar patterns. This still persists in much of the world. But this habit of growing locally adapted varieties and saving seeds to grow for next year is changing in the developing world now. But things have worked differently in the US for a long time. While many of our immigrant ancestors probably brought seeds from home when they first traveled to the US and diligently saved them for many years, Americans have, for the most part, been buying seeds from seed companies since the early 1900s. Instead of individual farms serving as the repositories of diversity, we allowed the experts at the seed companies to do so. They're really good at what they do, but they aren't particularly motivated to preserve diversity and instead prefer to sell seeds that do well in a large range of conditions and that will have high yields and pretty good tolerance to common diseases. The result of this was an alarming loss of diversity in seeds one could readily purchase to grow in a home garden or a truck farm. A 1983 study showed that in 1903, there were 544 varieties of cabbage for purchase in the US. By the early 80s, there were only 28. So 544 to 28, that's a tremendous loss in 80 years. Carrots went from 287 varieties to 21. Some of those are those flavorless objects the food industry sticks on a lathe and whittles down into so-called baby carrots that we've all munched on, right? Cauliflower went from 159 varieties to a mere 9. Now, maybe you're not terribly fond of cabbage or carrots or cauliflower, but chances are you might have found some of those lost varieties to be far more interesting and flavorful to eat than what we're left with now. On top of this, agriculture around the world is becoming more and more uniform. There's evidence that, on average, most countries are growing more species of crops than they used to, but we're all growing the same things. Maize was once cultivated exclusively in the New World, so it was domesticated in Mexico and stayed in the New World until the Europeans came and took it elsewhere. But now it's grown almost everywhere. Specialty grains adapted to local ecosystems, things like pearl millet, which grows even on the edge of the Sahara, or amaranth, which can withstand saline soils, are being abandoned in favor of crops like wheat or maize or rice that might have a higher yield, but could very easily fail if irrigation systems fail or fertilizer isn't available. For now, these high-yielding crops can help nourish hungry people, and that is not something I want to discount. But when we run out of groundwater, or when climate change brings about extended droughts, real long-term food security will be imperiled because genetic diversity formerly stored in these farms will have been lost permanently, with the exception of things that are stored in those seed banks, but that's always just a tiny sample of what used to be out there. This may sound like a problem for the developing world, but we need to be concerned about it too. So what I'd like to do today is to encourage all of you to be a little bit more like Nikolai Vavilov. If you go home over break or call your parents or grandparents just to chat, start by asking them if they've ever saved any seeds. If they still have them, try growing some yourself this summer. If you don't have a place to grow things, bring them to campus. I'm sure that we can find room in the community garden for your family's heirlooms. Sorry. Food's really important to me. If your relatives, like mine, didn't save seeds, ask them if they remember any great varieties of crops they can't get anymore. There's some really fantastic sources for obscure varieties of seeds now. We're bouncing back from that low point in the 1980s, which was a low point in many, many ways, when few people gardened then, and even fewer had an interest in rare varieties of crops. If no one in your family has any memory of now hard-to-find foods, start exploring your local farmer's market. Even here in this relative desert of crop diversity, more and more small-scale farmers are growing a fascinating array of foods. Find out what a real carrot tastes like and support your local farmers. And equally important, support crop diversity. Thanks and have a great spring break.
Thank you, Professor Ingram. All right, we have a few announcements. Tonight, Sigma Tau Delta will be sponsoring an open mic night at the Lilly Library. The film Not One Less will be playing in Corp Classroom at the Fine Arts Center, and the track and field team will be at Granville, Ohio for the NCAC Indoor Track and Field Championship, looking for the 4th league title in a row. Spring break starts this weekend. 2 things. Give some support to your brothers that are retaking comps over break. Good luck to all of you, and just know that we're all looking forward to crossing that stage with you in May. And finally, have fun, relax, and have a safe spring break. Thank you. Please rise and sing Old Wabash.